Okay, in this video I'm going to be introducing how we can convert matrix algorithms into computer code. And I'm going to demo this using the matrix product. So how can we have a computer compute the product of two matrices? As an example, one of the main programming functions that you need to use is loops. You need to be able to loop over a matrix when you're dealing with matrix algorithms. And kind of the primary motivation introducing you here is so that you will have a better idea of how to implement algorithms to that deal with matrices like Gaussian elimination for solving sets of linear equations. Let's dive right in. Let's talk about matrix multiplication first of all. So if I have two matrices, matrix A and B, so let's say I have a matrix A and this matrix A is going to have 3 rows and 2 columns, and then we're going to multiply this matrix using the matrix product by another matrix B, and let's say B here, we know that inner dimensions have to agree, so it needs to have 2 rows, but let's give it 4 columns. Okay, so if I were, that's going to result in a matrix C such that C is going to have dimensions of the outer dimensions, so 3 and 4, so 3 rows and 4 columns. So if I go ahead and kind of write these matrices out, could write them like this. So here's A, and A has A11, A12, A21, A22, A31, A32. Okay, here's A. So 3 rows, 2 columns, and using the convention for matrix multiplication that I taught in a previous video, I'm going to line them up like this. So now B, this is B11, and then there's a B12, a B13, and a B14, and it has a second row, B12, B21, sorry. Let's erase that here, make it a little more clear. So B21, B22, B23, and B24. Okay, when we multiply those together, we're going to get the C matrix, which I'll draw here. We know we can multiply A and B together because they make a square up in this corner, okay? So, and the dimensions of C are now conveniently the rows of A and the columns of B. So this is C11, C12, C13, C14, C21, C22, C23, C24, C31, C32, C33, and C34. Alright, so let's just talk about this. If I want to get, if I want to calculate the matrix product here, of A and B, essentially what I need to do is for each value, I'm going to kind of write down the algorithm for matrix multiplication in words. So for every component of C, let's use our color here, of C, which is 3 by 4, calculate its value as the dot product of the row of A and column of B corresponding, here I need to give myself a little bit more room here. Let's see here. Corresponding to the component of C. Alright, so that's kind of the algorithm for matrix multiplication written in words. And literally what it means is if I want to calculate, say, this component here of C, C22, to do that, I need to take the dot product between this row of A and this column of B to calculate the value of C. But this is an algorithm, the description of the matrix product algorithm in words. And so one thing that a scientist or engineer needs to be able to do is to be able to look at an algorithm like this and start to see how you could implement this algorithm in code. So there's key words that should jump out to somebody who's implementing an algorithm in code, that kind of, when you see those words, you start to see code that you could actually use to implement that algorithm. So some of the key words in this description of the algorithm are for every component. That means I need to make a calculation for every single component of the C matrix. And what calculation do I need to make for each component? I need to do the dot product of two pieces of information that correspond to that component. So what I'm going to teach you is how to access in a systematic way every single component of this matrix. And to do that, we use nested for loops. So if I have this matrix has a certain number of rows, so has a certain number of, columns. So these are the columns of C, okay? And then it has a certain number of rows as well. Rows, okay? And what we can do is we can use two for loops that loop over the rows and the columns of C, and we'll nest them together. So essentially what we do is, if I have one for loop that represents the row, let's represent the row as the row index as I. So for I equals 1 to the number of rows, we're talking about the C matrix here. We're looping over the C matrix, the rows of C. And then we're going to have another for loop inside this for loop for, I'm going to call the index relating to the columns is J. For J equals 1 to the number of columns of C. Then in here I'm going to say compute C I J is equal to the dot product and the dot product of, we're going to use the dot product of the height row of A and the jth, sorry, this should be, yeah, that's right, and the jth column of B. And then end this for loop, and then so that's this for loop right here, and then we're going to end the other for loop. So that's essentially the code that we could write. It's going to loop over the column, so we'll see this loop when I is equal to 1. We're going to come in and we're going to start this for loop, and it's going to loop from J equals 1. It's going to start out J equals 1, then it's going to go to 2, then to 3, then to 4, all the way. Let's see how many columns do we have in C? 4. So 1, 2, 3, 4, and then so this is I equals 1 still, and it's going to loop through there, and then it's going to I is going to be incremented again. I is going to be incremented to 2, and then J is going to be, the J loop is going to run for 1, 2, 3, 4 iterations, and then I is going to be incremented to 3, and then it's going to do it all over again. So each time, for each iteration of this loop here, we're going to run this loop. So this loop right here gets repeated the number of rows times. So we can see that we can use a structure like this, a control structure of nested for loops. This is called nested for loops. To access all the components of a matrix. Alright, well now I actually want to write the code. So I'm going to show you how to do this in MATLAB. And whoops, knocking stuff off my desk here. So I'm going to bring MATLAB over here into the screen, and I've opened up a new function. I'm going to give it a title. I'm going to call this matrix, we'll just call it matmul. That's a common name for a matrix multiplication function. And it's going to take two matrices. I'm going to call them A and B, and it's going to return the product of those in the matrix C. Now, what do we need to put in here? Well, the first thing we need to know is we need to know how big C is going to be. So, how big is the matrix C going to be? Well, if you remember from our function here, so C itself was equal to, has the same rows as A and the same columns as B. So if we come back into our code and we pass in a matrix A and B, then we can say, so this is our question. Okay. The answer to that question is C will have the same number of rows as A and columns of B. And I guess I should make this actual English. And same number of same number of columns as B. Okay? So MATLAB has a nice function called size, and if I create a matrix here, I can just say A equals rand 3, 2. So this is a 3 by 2 matrix, 3 rows, 2 columns. If I type in size of A, it returns a row vector that has the number of rows of A and the number of columns. So I could actually take a row vector and put in 2 variables. So say AR stands for or RA, the rows of A, and then CA is the columns of A, and set that equal to the size of A. And now I can see RA, which is the rows of A, is equal to 3, and CA, which is the columns of A, is now equal to 2. So I can do that same calculation up here in my function. So I can say rows of A, comma, columns of A is going to be equal to the size of A. And then I'm going to copy this. Copy. Paste. And put in B here. So now I can get the columns of A and B. Oh, that's cool. Alright, rows A, columns A. Why does MATLAB not like this? The values assigned here. Okay, it just says I haven't used it yet. Okay, so now I can create a matrix C. So create a C matrix that has the right dimensions. And I'm just going to create it using the zeros function. So I'm going to say C equals zeros. So it's just going to create a matrix, and it's going to have the rows of A and the columns of B. Alright. So that's going to create a matrix that has of zeros, filled with zeros, but it's going to be the right size for C. Okay, so now we've created the matrix C. Now we just need to loop over all the components of C using 2 for loops, and for each component of C we need to compute the dot product of the corresponding row of A and column of B to get the value for C. So I'm going to say loop over every component of C and calculate its value. Okay, so I'm going to have to use 2 for loops. So I said we were going to loop over the rows first and then the columns. So we'll use I for the rows. I equals the row value index is going to start at 1, so we're going to start at row 1 and go until the rows of A, which is how many rows C has, and then end that for loop. Then inside here we're going to have another for loop. J is going to be the columns. For J equals, going to start at the first column and go till the columns of B. And then in here I need to put the dot product. Calculate Cij as the dot product of the ith row of A and the jth column of B. Alright, so I'm going to say C, and to access its components I use parentheses. So I comma j, that's going to access the ith row jth column of C, and set that equal to the dot product. Now to do the dot product I can just do it like this. I can say the matrix product of the ith row of, so we want the ith row, so we pass in I for the row index, then we want every single column. We use the colon operator that grabs every column. So this A open parentheses I comma colon close parentheses, that represents the ith row of A. Multiply that by the jth column. So here we want every single row, the jth column of B, and that should work. And so now we can run that, and so I'm going to go ahead and save it. Matmul, I have a tutorials folder here. I'm going to save it in, and then I'm going to switch over to my tutorials folder. Now I can come in here into the command window. I'm going to create two matrices. I'm going to call it, instead of A and B, I'm going to call it, let's call it H and M. So H is going to equal some random matrix, and I'm going to give it 3 rows and 2 columns. So there's H, and then M, I'm going to give some random matrix that's going to have 2 rows and 4 columns. So now I've got H and M, and now I can say let's set V equal to the matmul, which was what we named our function, of A, let's use H and then M, and get our matrix product of those and set it equal to V. And there we go, we get V. Now can we check if this is right? Well, MATLAB does matrix multiplication just using by itself, so one way we can check is just say H times M, and we should get the same thing. And look at that. Here, let's see here if I can, there we go. So here's the function we called that we wrote that did H times M, and we get this value. And then we did H times M just using MATLAB's built-in multiplication operator. We get the same thing. So it's working just fine. So the takeaway from this lesson is, okay, if I want to calculate, let's just write this down, okay, some of the takeaways here. So, alright, so summarizing, takeaways, okay? First, I wanted to show you kind of how to think about matrix algorithms. So, how to think about matrix algorithms. So primarily, I wanted you to be able to see that what you need to identify is, from the algorithm, is identify what you need to calculate. What you need to calculate or compute. So reading through the algorithm in words, it said for every component of C, that meant we had to loop over every component of the C matrix. Now that's not always true. Sometimes you might be asked to do something like in naive Gaussian elimination to introduce a 0 into a certain part of the matrix. And so you don't actually have to loop over every component of the matrix, just a part of the matrix. And so I'm actually going to try in another video show you how you would actually get set up to implement naive Gaussian elimination. The other takeaway was, okay, how to use nested for loops. Nested for loops to loop over a matrix. So that's how do you access all the components of the matrix. Now, a question that I'd like to ask you that you should challenge yourself to is, okay, if I have some matrix with some number of rows, say we've got m rows and n columns. Actually, let's just do a square matrix for this case. So m rows and m columns. Now what if I just wanted to loop over the portion below the diagonal? So this portion down here. Okay, and I didn't want to loop over this portion up here, this green portion. Okay, I don't want to loop over this part. I only want to loop over and access these components down here. Okay, so if you wanted to do that, how could you do it? Well, you're going to have two for loops again, because you're going to have some index that runs for the rows and something for the columns. So for I equals something to something else, and then for j, this was the columns, equals something to something else, and then end. Okay. But what do we actually have to put in for these numbers here? If we're looping over the number of, if we only want to loop over this portion, highlighted here, let's highlight it in blue, okay? So this blue portion here, are we going to start our row index at the first location? No, we're not. We want to start it at 2, actually. So the number here would be 2. And to what row do we want to go to? Well, we want to go to the last one. So 2 to m. Now, the columns are even trickier, because when I'm on the first row here, what column do I want to start at? Well, I want to start at the first column, and I only want to include the first column. And then the third row here, I want to start at the first column and go to the second column. And then the next row I want to go first column to third column. The last row, first column to fourth column. Okay? At least for this example. I'm putting in numbers here, but really I should be talking about it a little bit more abstractly. So here, you might think I need to start at column 1 every time, right? So column 1 and go to some other column. Well, M, here we might want to go to I minus 1, right? So, because I minus 1 is going to be, here I is 3, and we want to go to the, so if this is the third column, I don't want to come here, I want to go to the I minus 1 column. And here I is 4, I want to go to the I minus 1 column here. So this should work. Anyways, you need to be able to think in how, if you just want to calculate a portion of a matrix, how to access that using nested for loops and the appropriate indices. So that'll help you get set up to implement algorithms like naive Gaussian elimination. Alright, so I'll talk about that in the next video, and we'll see you in the next video.